again, knowing our transformations here, I have y equals 2 times b raised to the x minus h plus k. Let's call this an A. Right? Whereas the b, even though b does affect the graph, like I said, the larger the value b is, the faster this graph increases if it's a growth equation, right? But b is actually not really, I mean, you can think of it, I mean, as like a stretching, but it's not going to be actually, a transformation. It's not going to affect any of our reflections and so forth. So in this case, we have a, which you can see that's 2. So that's going to tell us what is going to be our new y-intercept. It's going to be our y-intercept. So we just do 1, 2, make a nice big dot. Okay. 2 is also going to vertically stretch. It's going to vertically stretch. So that's going to be our y-intercept. Therefore, you can see here it's x opposite of h. So x opposite of 2, or I'm sorry, x. This is not. So therefore, you could write this as -2. So x opposite of 2, which would be x is going, or h is going to equal -2. X opposite of h. X opposite of h. Huh? No, it's negative. Do you see how x minus a -2 is the same thing as x plus 2? So x minus h. X minus h. H is equal to -2. So x minus 2, what is that doing? Is that shifting the graph to the left or to the right? To the left. Remember, it's always the opposite of what this is. My actual h value is negative. That means you're shifting it to the left, right? So therefore, instead of my graph actually crossing at 0, 2, it's going to be crossing over here. Do you guys see that? So this point just got moved, right? And all I wanted you guys to do is graph with one point. That's all I wanted you guys to do. So rather than the graph looking like this, right? That's what a typical growth function, because that b is larger than 1, so it'd be a typical growth function. Well, now it's just going to look something like that. And then we still have our asymptote. Since we didn't move up or down, my asymptote is still going to be right there. All right. Any last questions on that? Yes.